All right, so now let's look at doing cookie. And again, this is all review stuff, and then we'll work down to Gorilla and Memcache and bcrypt. And bcrypt's for storing passwords and encrypting them. And so to do a cookie, right, I always like to start with just what are my routes. And so handle func, HTTP handle func. At this route, give it this function. Well, here's that function. And then listen and serve, stand up the server and have it listened there. We're using default serve mux. So details, right? And so this function gets called. And the first part of it is from the request. So a request comes in, and anytime a client makes a request to the server at a certain domain, if the client has a cookie for that domain, the browser will automatically send the cookie for that domain that it's making a new request for to the domain to whom the cookie was originally from. And so we're saying from the request that just came in, get a cookie, request.cookie. And so we can look at request.cookie here. So where would we find HTTP request, right, in the docs? So go back to the docs, and I'm guessing it's going to be net HTTP, and then just come down here, and there's the request. And one of the things is if we have a pointer to a request, right, we have all these methods right here available to us. So the R and pointer to a request, that's the receiver over here on the left. And when something has a receiver, when a function has a receiver, that function is now a method, and that method is attached to anything that's a pointer to a request. So we get a request back, and that request that we're getting back right here is a pointer to a request, right? That's just the way this is set up. That's pretty much standard out of the box Go web programming. You have your response and your request. So the request is coming into the server right here. That comes into the server, and the response is going out to the client. So we receive the request, and then we do stuff with it, and then we write back our response, and it goes back, you know. And so we get our request, pointer to a request, and we have all these methods available. So we have a pointer to a request, so we could call any of these, and we're saying, hey, we're doing cookie, and we give it a name, and it gives us a pointer to a cookie and an error, right? So right here, request cookie, give the name of the cookie. So it's, you know, you're a web developer, you create an application, you want to write a cookie from your server on the client. You call a cookie whatever you want. And then when it gets written on the client. And then later when you want to access that, you say, hey, is that cookie called thingamajigga? Right there, is it available? Is cookie thingamajigga available? Right? And then you get it back. And it gives you a pointer to a cookie. Right? Pointer to a cookie. We're still in net HTTP, but it's like, here's the cookie. Has a name and a value, and they're both strings. And then there's some other stuff, like max age we'll use to blow the cookie up, get rid of it. Right? But when we have a pointer to a cookie, all we have is string available to us. I thought there might be more. That's it. Just look and see if there's anything else. All right, so we ask for the cookie logged in, right? And if there's no cookie, so there's an error, right? Error. And the error is HTTP no cookie. So there's no cookie, so great, let's create one. And this is how we get the address of something. So we create the cookie, right? And we give it the name and the value. It's a struct, so we just say, hey, this field, this value, this field, this value. And name and value, we saw that both takes strings. So just to look back at cookie here, right? Name is a string, value is a string, this is a struct, just a collection of fields. And so here we get we create our struct here and give it some values, and then get the address of it and assign it to cookie. So if there's no cookie, we threw an error. If that error is no cookie, create a cookie and store it in that variable.
The address of the cookie, is that being created
as you create this right here, it gets stored in some address, and then we're saying, show me that address.
Okay.
And that means we now have that variable is of a type pointer to cookie. So it's just the exact same type that we got back when we asked for request cookie, because request cookie gives us a pointer to a cookie. And that means I've got the address where a cookie lives. I'm pointing, I have the memory address, right? That's what's stored there. And I'm pointing to a memory location with that address where the cookie lives. Which one?
If there's no cookie, then it returns an error, and the
Yeah.
error then creates a cookie.
Yeah, we check to see, hey, was there an error that there's no cookie? And then we manually just wrote this code right here. So that's just a conditional if statement, right? And so if there is an error and it's equal to no cookie, that's true, so it runs that chunk of code.
I guess the problem I'm having is it's not a colon equals, it's just an equals. So
yeah, so great, that's great. So why not colon equals right here?
Yeah, because there's no cookie.
And because we've already defined a variable cookie, which right now is nil, because no cookie got returned.
Yeah.
So we have it. And now we're going to say, okay, that variable, because when I highlight this one, right, like those are that's all the same variable right here, right? So it's already been declared, so I don't need to redeclare it. And so the colon equal is for shorthand for declaring and initializing, assigning, and then if I want to reassign, I don't have to declare, so it's just equal. The variable's already been declared. This is a cookie.
Okay, I'm looking for the place where the cookie's address, its location has been created. That doesn't happen until the if routine?
Yeah, that's a good question. So I'm not sure if right here when we get a request cookie and it returns an error, if this is nil, it means there's no address yet. And so I think in that case it's being created right here.
Okay, that was the question.
I think that's the case, yeah. Because why would we have an address when there's no value, right? We don't need to store anything. But I have like 87% certainty on that answer. And then we check again the request method here. So no cookie, right? And then right here we're going to check to see if they're logged in. So if the request method is post, meaning a form has been submitted, and the form that's submitted comes from down here, right? And so here's a form. And so if we've run this chunk of code where a form got submitted, then the request method will be post. And we could run this code. And what this code does is it checks first the password that was entered, request form value password. We assign that to a variable, and then we say, is that value that was entered equal to secret? Because that's the password you need to log in. So if this is a real app, we would check right there user credentials against a data storage of some sort, right?
Yeah.
But we're just saying anybody can log into this app if they know the password is secret.
Okay, but if somebody logs in and it asks them to make a password and they try secret, and they say that one's already taken.
Yeah, that's not the intent of this app, right? No, yeah. So let's just see it running, and then that'll help us understand this a little bit better. I'm using go run main now, not go app serve, because this is just an executable, and it's not an app engine. We have no app YAML right here, just straight up go, no app engine. And localhost 8080 asked me to log in. I could use any username. If I put in some password like me, nope, doesn't like it. But if I do any username secret, I'm logged in. And then I can log out. And what's happening there is if we go and look at the cookies under resources, I just came into developer tools, if you're watching this online, and go into more tools, developer tools, right there. And that launches the developer tools. More tools, developer tools. There's also a shortcut on the Mac. It is Command Option I. That's Option, I think. So let's just do that. Command Option I. Yeah, there we go. And I go to Resources, and I go to Cookies and Localhost. And so there's my cookie, and you can see logged in right now is 0. And then delete that cookie, and then just hit refresh. No cookie or anything. But as soon as I log in, right, wrote the cookie, the value is 0, or the value is 1. and I log out, and the value is it's just gone. It deleted the cookie. I told it to, so that's not a surprise. So that's the basics of the app, right? Just like how can we do some basic storage of user information in a cookie, and so we're just doing a name and a value. If we want to store additional information in the cookie, right, the value takes a string, and so we could just serialize any kind of information we want as JSON and store the JSON there. It's a big string of data, right?
-1 is 1 second?
Yeah, -1. Max age, when you're looking at a cookie, max age is right here. So part of that struct, which is a cookie, and anytime it's less than 0, is means max age is nothing, right? So delete it. All right, so when it's post, where does this come from? Where is that value established? What's happening with this line right here?
Is that in the HTML?
Yeah, that's in the HTML. And is it going to be name or ID on the form? Which field? The name field or the ID field?
The name field.
The name field, because we're naming a variable, right? And the variable is going to hold the value that the person entered in the field on the form. And so here we've got name, password, right? And we don't need ID, but that's where the password comes from, which we're checking right here. Request form value password. But the name is like, what's the variable name you want for whatever's entered in this field? Right? I want that to be password. And that's different. You'll often see ID too. Right? And often these will be the exact same thing. So what's ID used for? CSS and JavaScript. Right? And I think you could also do name with JavaScript. You could probably do name with CSS. But ID is more like, let me identify that object in the DOM. Let me identify it. What's its ID? And name is like, oh, what's the name of the variable where I'm storing whatever was entered? So that's kind of cool. I remember when I learned that, I was kind of like, that totally makes sense. I used to always get name and ID confused and wonder why you needed both of them. So that's just like, right? Seeing if they're logged in, and if they are logged in, if they have the password, we set the value to 1. And notice that even with the cookie name logged in, they could not be logged in, right? The value could just be 0 or off, or 1 on. And so then if they go to the /logout, we take the cookie and we set the value to 0, and then we say max age -1, which deletes the cookie. So that's a little bit redundant, those two lines right here, setting the value to 0 and then deleting the cookie. But I don't know. Maybe, some browser won't pay attention to max age. So
you could delete it and leave the value line out, right?
Yeah, you could delete it and leave the value age out. Be the same. But that's like double.
It's a fail-safe kind of thing.
Yeah, fail-safe, because there's some browser out there that doesn't pay attention to it or something, which I'm sure there's not, but whatever. And then we set the cookie, right? So there's a couple different things the cookie could have become, right? We could have got the cookie right back, and if there's in which case, and they weren't logging in, there's just a cookie there, and we already have a cookie, they're already logged in, and they're not logging out, in which case the cookie here just gets set right back. Or there's no cookie, we create the cookie, and then that gets set right here. Or they were logging in, and then we, set that right here. Or they were logging out, and then we set that right here. So that's all the functionality of our cookie. It's kind of cool. I really like this example.
Is this set up so that if you didn't delete the cookie, that when you go back to the top of the routine and it says, is there a cookie? Is that going to be a cookie for this particular user? Or just any old cookie? I mean, is this set up to define that? I guess the cookie's on the client computer, so there's only going to be one anyway, right?
Yeah.
And it's going to be defined for that user.
Yeah.
Okay. That's where it's going to find the cookies on the client.
Yeah. Yep.
Okay, never mind.
All right, so set cookie. And then we create a variable called HTML of type string. That HTML variable is just the name. It has no special keyword significance or reserved word significance or anything like that. It's just a variable name. And it's of type string. And what we're going to store in that variable is a string. And it's going to be a string of HTML. And we're going to store either one string of HTML or the other. So we'll either store this chunk of HTML or that chunk of HTML. And then we're going to write our HTML out as our response. And guess what write string takes as its first argument? What does write string take as its first argument?
Writer.
A writer, right? And we've already learned that response implements the writer interface. So write string is asking for a writer, right? And the response implements the writer interface. So since write string is asking for a writer, we could give it the response right there. Could we have done this? Apparently not. Format, IO. I have to import that package. Could we have done that?
No.
Yeah.
There's a writer.
Because what does fprint take? Fprint, which isn't fprintf, so we're not doing formatting printing, right? Takes a writer. So we could have used fprint. Well, what's the difference between fprint and IO write string? I don't know. But it might be interesting to look up and see if there is a difference, right? But it's kind of cool starting to see how those interfaces allow you to access different functionality and sometimes accomplish the same thing in different ways. And so here we're going to say, hey, if the cookie value, what is the value? It's a field in the struct, which is cookie, right? And the value, there's the key and then the value. The name and the value, right? There's the name and the value. And so if the value is 0, what's that mean? Are they logged in or not logged in? 0 is not logged in, right? So up here, logged in, 0. They're not logged in yet. Logged in, now they're logged in, right? They got the password, so it's 1. So if they're not logged in, then we're going to give them all this code, which has a form to allow them to try to log in. That makes sense. And then if they are logged in, we're going to show them, so the value, cookie value is 1. We're going to show them the ability to log out. Snap. I feel like doing a little dance or something. Like that's magic right there. That's like, you have that, you're like super close to like, oh, I could start building some stuff. So why is it string convert I2A? First of all, what is I2A? I know this is review. What's I2A method? What's the I2A function? Sorry, what's the I2A function do from the string convert package? What's the I2A function do? Integer to ASCII. So we're taking an integer, 1, and we're turning it into ASCII. Why are we turning this into ASCII? Why are we making that a string? Why are we making the 1 a string? Because cookie value is a string, right? When we look at what a cookie is, the value is a string. So we can't compare a bool, we can't compare an int to a string. So our choices were to either make this one an int or to make this one a string. So we made that one a string, int to ASCII. Pretty sweet, huh?
Where's the cookie stored on the client computer?
Where's the cookie stored on the client computer? It varies based upon which browser you're using. Each browser stores cookies in different ways, different locations. And I have no idea where Chrome stores its cookies. I used to be able to dig them out with Internet Explorer.
Like app data /
Yeah.
You're in Mac, never mind.
And so if I had a cookie from somebody and I'm on Chrome and I go to that same website and Firefox, Firefox is going to be looking for the cookie in a different place. And I don't know if that's accurate, but I have like 92% certainty that that's correct, what I just described. Does that resonate with everybody else, what you understand? What I just described, how cookies are stored, they're browser specific, and the browser chooses the location, right? And if you are in one browser and you get a cookie, you go to another browser, and you go to the same place, the cookie's not there. Okay, so cool stuff. Good review.